Hello there, and welcome. Tonight I want to take you somewhere far away from the noise of your day, somewhere beyond the familiar walls that surround you, beyond the gentle hum of the world you know so well. I want to take you on a journey that requires nothing from you except your willingness to wonder, your openness to drift, and perhaps your readiness to let go of everything you thought you understood about the size of existence itself. So settle in, wherever you are. Let your body find its comfortable place. Let your breathing slow to match the rhythm of starlight traveling across the void. There is no rush tonight. There is no destination we must reach by any particular hour. We have all the time in the cosmos, and the cosmos, as you will soon discover, has more time than we ever imagined possible. Before we begin this journey together, I would love to know where you're joining me from tonight. Perhaps you're listening from a quiet bedroom in a city that never quite sleeps, the distant sound of traffic humming like a mechanical lullaby beneath your window. Perhaps you're in a small town where the stars shine a little brighter, where the night sky still remembers what darkness truly means. Maybe you are somewhere unexpected, a hotel room in a foreign country, a cabin in the mountains, a hospital bed where rest seems elusive, or simply your favourite corner of a home you've known for years. Wherever you are, whatever time the clock shows in your corner of this spinning world, you are welcome here. We are all travellers tonight, all of us looking upward into the same vast darkness, all of us connected by our shared wonder at what lies beyond. If you are enjoying this journey with me, if these words bring you some measure of peace or curiosity, I would be so grateful if you would consider subscribing to this channel. It helps more than you might imagine, and it means that you will be here for the next time we wander together through the mysteries of existence. A simple like too, if you feel moved to offer one, tells me that these gentle explorations matter to someone out there in the night, and please share in the comments where you are from, what time it shows on your clock, what brought you here tonight. I read every comment, and there is something beautiful about knowing that people across all the time zones of Earth are drifting into dreams together, united by the same cosmic questions. Now, let us begin properly. Let us step away from the small concerns that may have followed you into this evening and turn our eyes upward towards something so immense that it will make those concerns feel, if only for these few hours, wonderfully small. I want to ask you a question tonight. It is a question that might seem, at first, almost absurd. It is the kind of question that makes sensible people raise their eyebrows and perhaps offer a gentle, knowing smile, the kind of smile that suggests they have encountered such ideas before and found them wanting. And I understand that skepticism. I honour it even. There is wisdom in not believing everything we hear, in demanding evidence, in asking for proof before we reshape our understanding of reality. But tonight, I am not asking you to believe anything at all. I am only asking you to wonder. I'm only asking you to follow a thread of thought wherever it might lead, knowing that we can always find our way back to solid ground when the morning comes. The question is this, and I want you to let it settle gently into your mind like a snowflake landing on still water. What if the Milky Way, our enormous, spectacular, impossibly vast galaxy, containing hundreds of billions of stars, stretching across 100,000 light-years of space, what if this galaxy that we call home was only a single pixel in a much, much bigger picture? It is a question that sounds almost like poetry, almost like something from a dream rather than a scientific contemplation. And yet, as we will discover together over these quiet hours, it is a question that touches on some of the deepest mysteries in all of modern cosmology. It is a question that scientists have pondered, in their own careful way, even if they might phrase it differently. It is a question that leads us to the very edge of what human beings can know, and then invites us to peer over that edge into the beautiful unknown. You see, we humans have always struggled with scale. Our minds evolved on the African savannah, where the biggest concern was the lion in the tall grass or the storm cloud on the horizon. We learned to think in terms of distances we could walk in a day, in terms of time spans measured by seasons and generations. We became very good at understanding the world at human scale, the scale of our bodies, our villages, our immediate concerns. But the universe, as it turns out, cares nothing for human scale. The universe operates at magnitudes that our intuition simply cannot grasp, no matter how hard we try. And so tonight we will try anyway. We will stretch our imaginations as far as they will go, and then we will stretch them further still, knowing that even our most extravagant visions probably fall short of the reality that awaits us in the cosmic darkness. Let me paint a picture for you, a picture that will help us begin to understand what we're contemplating tonight. Imagine for a moment that you are looking at a photograph on a screen. Perhaps it's a photograph of a beautiful sunset, all oranges and purples and deep reds bleeding into one another like watercolors on wet paper. The image seems seamless to your eyes, a continuous flow of color and light that captures something of the original moment when someone pressed the shutter and froze that light forever. But now, imagine zooming in on that photograph. Closer and closer you go until the smooth colors begin to break apart into something unexpected. Suddenly you can see the individual pixels, those tiny squares of single colors that from a distance blended together to create the illusion of continuity. Each pixel is simple, just one flat color, one tiny contribution to the greater whole. And yet, without any single pixel, the image would be incomplete. Something would be missing, even if you could not quite say what. This is the metaphor we will carry with us tonight. We are going to wonder, gently and without any urgency, whether our entire galaxy might be something like one of those pixels. From our perspective, the Milky Way seems like everything. It contains our sun, our Earth, every star we can see with our naked eyes on the clearest night. It has taken humanity thousands of years just to begin to understand its structure, its size, its slow rotation over millions of years. The Milky Way is so vast that light itself, the fastest thing in the universe, takes 100,000 years to travel from one edge to the other. Let me say that again, because it deserves to be repeated, to be felt rather than simply heard. Light, traveling at over 600 million miles per hour, would need 100,000 years to cross our galaxy. If you could somehow stand at one edge of the Milky Way and shine a flashlight toward the other edge, and if someone on that distant edge were waiting to see your light, 100,000 years would pass before they caught even the first glimmer of your signal. Generations beyond counting would live and die. Civilizations would rise and fall. And still the light would be traveling, crossing that unimaginable distance 1 mile at a time. This is the scale of our home galaxy. This is what we mean when we talk about the Milky Way. And if this were the whole story, if the Milky Way were the entirety of existence, it would already be more than enough to inspire a lifetime of wonder. We would still have mysteries enough to keep us contemplating until the end of our days, but here is where things begin to get truly interesting, where the question we're asking tonight starts to reveal its full weight and beauty. You see, the Milky Way is not alone. It is not even close to alone. When astronomers first turned their telescopes towards certain fuzzy patches of light in the night sky, they argued for years about what they were seeing. Some believed these were merely clouds of gas within our own galaxy, bright nebulae of a type they had seen before. Others suspected something far more revolutionary, something that would change our understanding of the cosmos forever. And in the early 20th century, we finally got our answer. Those fuzzy patches of light were not clouds at all. They were other galaxies, other vast island universes, each containing billions upon billions of stars, each separated from our own Milky Way by distances so enormous that they make our galaxy seem almost cozy by comparison. The nearest large galaxy to our own, the Andromeda Galaxy, is approximately 2.5 million light-years away. I want you to try to hold that number in your mind, even though I know it will slip away like water through your fingers, because numbers like this were never meant for human comprehension. 2.5 million light-years. That means the light we see from Andromeda tonight, if we were to step outside and look toward the constellation that bears its name, that light left Andromeda 2.5 million years ago. When that light began its journey, there were no humans on Earth. Our ancestors were still learning to walk upright, still generations away from anything we would recognize as language or culture or civilization. The light traveled all that time, all those years, through the cold emptiness between galaxies, through the void where nothing exists except the faintest radiation left over from the birth of the universe itself. And tonight, after all that traveling, that ancient light finally arrives at your eyes, bringing with it a message from across the cosmic ocean. And Andromeda is close. In galactic terms, Andromeda is practically our neighbor. When we look deeper into space, when we point our most powerful telescopes toward the darkness between the visible stars, we find galaxies upon galaxies upon galaxies, stretching away in every direction until they blur together into a kind of cosmic foam, a structure so vast and so complex that it defies easy description. There are at least 2 trillion galaxies in the observable universe. Let me say that number again, slowly, because it deserves to be treated with respect. 2 trillion galaxies, that is a 2 followed by 12 zeros. That is more galaxies than there are grains of sand on all the beaches of Earth. Each of those galaxies contains, on average, something like 100 billion stars. Each of those stars might have planets. Each of those planets might have moons. The numbers become meaningless at this scale, not because they are untrue, but because our minds simply cannot grasp what they represent. And yet, and here is where our question begins to take shape, even this unimaginable vastness, this ocean of galaxies stretching across billions of light years in every direction, even this might be only a small fraction of what actually exists. You see, we can only see so far into the universe. We are limited by the speed of light and by the age of the cosmos itself. The light from the most distant galaxies we can observe has been travelling toward us for over 13 billion years, since not long after the Big Bang itself. Beyond those galaxies, there is more universe, almost certainly far more than we can see. But the light from those regions has not had time to reach us yet. It is still on its way, travelling through the darkness, carrying its message toward a destination it will not reach for billions of years to come. What we can see, what astronomers call the observable universe, is like a small circle of light cast by a lantern in an infinite dark room. Within that circle, we can see clearly enough. We can count galaxies and measure distances and make maps of the cosmic structure. But beyond the edge of that circle, beyond the limit of our observations, the room continues. The darkness extends in every direction, and we have no way of knowing how far it goes. Perhaps it goes forever. Perhaps the universe is truly infinite, stretching without end in all directions, containing not just trillions of galaxies, but an endless number of them. Galaxies beyond counting, galaxies beyond imagining, galaxies we will never see, no matter how long our species survives. This is the context in which we ask our question tonight. This is the framework within which we wonder whether our galaxy, our enormous, beautiful, incomprehensibly vast Milky Way, might be nothing more than a single pixel in a much larger picture. If the observable universe is merely a tiny fraction of the total universe, and if the total universe is perhaps infinite, then our galaxy is not just small, it is infinitesimally small. It is a speck of a speck of a speck, a single grain of sand on a beach that stretches forever in all directions. And yet somehow, here we are. Here we are, tiny creatures on a tiny planet orbiting a medium-sized star in one spiral arm of one galaxy, among trillions, and we are asking questions about the nature of reality itself. There is something almost miraculous about that. Something that fills me with a quiet, peaceful kind of awe. I want you to feel that awe tonight. I want you to let it wash over you like a gentle wave, not overwhelming, not frightening, but soothing in its vastness. Because when we truly understand how small we are, something strange happens. Instead of feeling insignificant, we begin to feel connected. We realize that we are made of the same stuff as the stars, the same atoms that were forged in the hearts of ancient suns that exploded billions of years ago and scattered their substance across the cosmos. We realize that we are the universe becoming aware of itself. Tiny fragments of the whole that have somehow developed the ability to look back at the whole and ask what it means. So let us continue this journey together, you and I. Let us drift deeper into the cosmic darkness, carried by curiosity and wonder. There is no test at the end of this voyage. There are no answers you need to remember. There is only the gentle pleasure of contemplation, the quiet joy of allowing your mind to expand beyond its usual boundaries. And if, somewhere along the way, you find yourself drifting into sleep, that is perfectly wonderful. The cosmos will continue its slow dance whether we are watching or not. The stars will continue to burn, the galaxies will continue to turn, and you will be held, always, by the same gravity that holds the planets in their orbits and the stars in their courses. You're safe here. You're welcome here. You're exactly where you're supposed to be. Now, before we continue deeper into our exploration, I want to acknowledge something important. The question we're asking tonight, the idea that our galaxy might be a mere pixel in some larger cosmic picture, is not something we can prove or disprove with our current science. It is, in many ways, a a question that lives at the edge of what science can address, in that mysterious borderland where physics meets philosophy and mathematics meets metaphysics. And that is part of what makes it so beautiful. We are not here to reach definitive conclusions. We are here to wonder, to imagine, to let our minds play with possibilities that may never be settled in our lifetimes. Think of it this way. Imagine that you are an ant living on a vast painting in a museum. All your life, you have explored the tiny section of canvas beneath your feet. You know every brushstroke in your small territory, every ridge of dried paint, every subtle variation in colour. To you, this small patch of canvas is the whole world. You cannot imagine that there is anything beyond it, because your perspective is too limited to see the larger picture. Now imagine that you begin to wonder whether there might be more. You have no way to travel to the edges of the painting, no way to step back and see what a human viewer sees when they look at the artwork as a whole. But you can wonder. You can hypothesize. You can imagine what kinds of forms and patterns might exist beyond your immediate perception. And in that wondering, something beautiful happens. Your world expands, not physically, but conceptually. You become aware, for the first time, that reality might be far larger and far more complex than anything you have experienced. This is what we are doing tonight. We are the ants on the canvas, wondering about the painting we cannot see. We are the pixels in the image, wondering about the picture we cannot step back from. And in that wondering, we are participating in one of the oldest and most noble human traditions. The tradition of looking up at the sky and asking, what else is out there? What else might be true? What else might be possible? The history of astronomy is in many ways a history of discovering that the universe is far larger than we thought. Every time we have believed we found the edge of existence, the boundary of reality, we have been wrong. And every time we have pushed past that boundary, we have found more, always vaster, always more beautiful and more mysterious than we imagined. There was a time when humans believed the Earth was the center of the universe, and everything revolved around us. Then we discovered that Earth orbits the Sun, and our planet was demoted from the center of existence to merely one of several worlds circling a star. Then we discovered that the Sun is just one star among billions in the Milky Way, and our solar system was demoted from being special to being ordinary. Then we discovered that the Milky Way is just one galaxy among trillions, and our galaxy was demoted from being everything to being almost nothing at all. Each of these discoveries was, in its way, humbling. Each of them stripped away a layer of cosmic importance that we had assumed was our birthright, and yet each of them was also liberating. Each of them freed us from a small, cramped view of reality and opened us to something far more magnificent. When we learned that the Earth was not the center of the universe, we gained access to the whole solar system as a realm for exploration and understanding. When we learned that the Sun was not unique, we gained access to the lives and deaths of stars, to the nuclear furnaces that create the heavy elements, to the cosmic cycles that seed the galaxy with the building blocks of life. When we learned that our galaxy was not alone, we gained access to the entire observable universe, to the cosmic web of galaxies and clusters and superclusters that stretches across billions of light years in every direction. And now, tonight, we are contemplating the possibility that even the entire observable universe, might be only a tiny fraction of what exists. We are contemplating the possibility that reality is so vast, so unimaginably large, that everything we have discovered so far, every galaxy, every star, every planet, every atom of matter in the visible cosmos, might be nothing more than a single point of light in a picture so large that we cannot even begin to perceive its outlines. This is not a humiliation. This is not a reason for despair. This is an invitation to wonder, an invitation to awe, an invitation to feel the full weight and beauty of existence pressing gently against our small, finite minds. Let me share something with you that I find deeply comforting on nights like this. When I consider how small we are, how insignificant our little planet seems against the backdrop of cosmic immensity, I find that I do not feel diminished. I feel instead strangely grateful to exist at all, grateful to be conscious, to be aware, to be capable of asking these questions and feeling this wonder. Because here is the thing that often gets lost when we talk about how small we are. We are here. We exist. Against all odds, against all the vast improbability of matter, organizing itself into life and life organizing itself into consciousness, We are here, having this conversation, wondering these wonders, feeling these feelings. That, to me, is the real miracle. Not that the universe is large, but that we are here to notice it. And there is something else, something that connects us to the cosmic vastness in a way that is both humbling and exalting. Every atom in your body was forged inside a star. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it was cooked inside the nuclear furnaces of ancient suns and scattered across the galaxy when those suns died. You are, quite literally, made of star stuff. You are the cosmos looking back at itself. When you gaze up at the night sky and wonder at the beauty of the stars, you are stardust, wondering at stardust. You are the universe, in one small, temporary, precious form, becoming aware of its own magnificence. So when we ask whether the Milky Way might be only a single pixel in a larger picture, we're not asking a question that diminishes us. We're asking a question that connects us to something infinite. We are recognizing that we are part of something so vast and so beautiful that our minds can barely begin to comprehend it. And in that recognition, there is a kind of peace. There is a letting go of the need to be central, to be important, to be the point of everything. There is an acceptance of our place in the cosmic order, small but essential, temporary but connected to the eternal. Tonight, as we continue this journey, I want you to carry that feeling with you. I want you to hold it gently in your heart, letting it warm you as you drift deeper into contemplation and eventually into sleep. You are part of something magnificent. You are a pixel in a picture so vast and so beautiful that no human eye will ever see it in its entirety. And that is not sad. That is wonderful. That is the most wonderful thing I can imagine. Now let's pause here for a moment. Let your breathing settle. Feel the weight of your body against whatever surface supports you. Notice the gentle rhythm of your heartbeat, that faithful drum that has been keeping time for you since before you were born. The cosmos can wait. The galaxies will not go anywhere while you rest. Let this moment be enough, this quiet space between ideas, this gentle pause in our journey together. In the sections that follow, we will explore our home galaxy in more detail, coming to appreciate its beauty and its vastness before we zoom out to consider larger scales. We will think about what it means to be a pixel, what the metaphor reveals about our place in existence. We will consider the limits of what we can observe and what might lie beyond those limits. And we will wonder, always gently, always peacefully, about the nature of reality at scales that dwarf everything we know. But for now, just breathe, just rest. Just let the wonder settle into you like starlight filtering through darkness. You have nowhere else to be. There is nothing else you need to do. You are exactly where you are supposed to be, a conscious speck of cosmos drifting through the night, wondering at the beauty of it all. The journey continues. The cosmos awaits, and you, dear listener, are invited to come along at whatever pace feels right, in whatever way brings you peace. Welcome to the infinite. Welcome to the mystery. Welcome home. Let us take a moment to appreciate something quite remarkable about this very instant. Right now, as you listen to these words, as your mind forms images and ideas from the sounds you hear, your brain is performing miracles of computation that we still do not fully understand. Billions of neurons are firing in precise patterns, creating the experience of consciousness, creating you. And all of this is happening on a small planet, orbiting an ordinary star in one arm of a spiral galaxy, in a universe that may extend forever in all directions. The very fact that you can contemplate infinity is itself infinite in its implications. The very fact that stardust can wonder about stars is a mystery that no science has fully explained. When ancient humans first looked up at the night sky, they saw a dome of lights, a ceiling above the world that they populated with gods and stories and meaning. They did not know that each of those lights was a sun, many of them far larger and brighter than our own. They did not know that the pale band of light stretching across the sky, which we now call the Milky Way, was the combined glow of hundreds of billions of stars, seen edge-on from our position within the disk. They did not know that the darkness between the stars was not empty, but filled with dust and gas, and beyond our galaxy, with countless other galaxies stretching to the edge of visibility and beyond. And yet, even without this knowledge, They felt something that we still feel today. They felt the wonder. They felt the awe. They felt the deep, almost physical pull of the infinite, calling them to look up and question and dream. We are the inheritors of that wonder. Every culture that has ever existed has had its stories about the stars, its explanations for the lights in the sky, its attempts to understand humanity's place in the cosmic order. We have cave paintings that may represent the stars. We have ancient monuments aligned with celestial events. We have myths and legends that place the gods among the constellations, that see the night sky as a window into another realm, a place where the eternal intersects with the mortal. And now, in our modern age, we have science, that extraordinary method for testing our ideas against reality, for building up knowledge piece by piece until we arrive at truths that our ancestors could never have imagined. Science has not diminished the wonder. Science has multiplied it beyond measure. Every discovery we make opens up new questions, new mysteries, new realms of the unknown. When we discovered that the Earth orbits the Sun, we opened up the question of whether other stars might have planets, and whether life might exist on those planets. When we discovered that our galaxy contains billions of stars, we opened up the question of what structures might exist at even larger scales. When we discovered that the universe contains trillions of galaxies, we opened up the question of what lies beyond our ability to observe in the vast dark regions where no light has yet had time to reach us. And now, tonight, we are opening up a question that pushes even beyond those questions. We are asking whether everything we can see, everything we have discovered, everything we know or will ever know might be only an infinitesimal fraction of what exists. We are asking whether reality itself might be so vast that our entire observable universe is like a single cell in a body beyond comprehension. We are asking in the most fundamental terms just how big the picture really is. I want to be clear about something. I do not know the answer to this question. No one does. We may never know. The question may be in principle unanswerable, at least with the tools and methods available to beings like us. But that does not mean the question is worthless. That does not mean we should not ask it, because the asking itself changes us. The wondering itself expands our minds and deepens our appreciation for the mystery in which we find ourselves. And in a cosmos that may be infinite, the capacity for wonder may be the most precious thing we possess. So let us continue to wonder together. Let us drift a little further from the shores of the known and into the deep waters of possibility. There is no danger here. There is only the gentle current of curiosity carrying us where it will. Close your eyes if you like. Let the words wash over you like waves on a distant shore. Let your breathing slow. Let your muscles relax. Let the cosmos hold you as it holds everything, with the gentle, implacable force of gravity, that most patient of all forces, that slow embrace that keeps galaxies together and stars in their courses, and you, right now, pressed softly against the surface of your small, beautiful world. We're all falling, you know. Every moment of every day we're falling toward the center of the earth, and only the solid ground beneath us prevents us from continuing that fall. The earth, in turn, is falling toward the sun, caught in its gravitational embrace, tracing an ellipse through space that takes a year to complete. The sun is falling toward the center of the Milky Way, orbiting the galactic core once every 230 million years. And the Milky Way itself is falling toward other galaxies, drawn by their gravity into the slow cosmic dances that shape the universe at the largest scales. Everything is falling, always falling, and yet everything is held. There is a deep peace in that realization. We are falling, and we are held. We are small, and we belong. We are temporary, and we are part of something eternal. Let that feeling carry you forward into the next part of our journey. Let it be the foundation on which we build our explorations. Because as we look more closely at our home galaxy, as we come to appreciate its structures and its mysteries, we will need that feeling of connection. We will need to remember that we are not observers looking at the cosmos from outside. We are participants embedded in the fabric of reality, made of the same matter and energy that makes up everything else, subject to the same laws that govern the largest galaxy clusters and the smallest subatomic particles. We are not separate from the universe. We are expressions of it. We are the universe in one particular form, wondering about itself. And that, perhaps, is the deepest mystery of all. Not the size of the cosmos, Not the number of galaxies, not the possibility that our reality is only a pixel in a larger picture. The deepest mystery is consciousness itself, the fact that matter can organize itself in such a way that it becomes aware, that it asks questions, that it feels awe and wonder and love, that mystery is with you right now, as close as your own thoughts, as intimate as your own breath. Whatever else is true about the universe, this is true. You are here experiencing it, and that is miraculous. So rest now, as we prepare to go deeper. Let the questions settle into your mind like seeds planted in fertile soil. They will grow, in their own time, in their own way. There is no rush. The cosmos has been here for 13.8 billion years. It will be here for billions more. And somewhere in all that time, this moment exists, this conversation exists, this wondering exists. Right now, right here, between you and me and the stars, in the silence between thoughts, the cosmos breathes, and so do you. Let that be enough for now. Let that be everything. As we begin to transition toward the next chapter of our exploration, I want you to carry with you the feeling we have cultivated here, the feeling of peaceful vastness. The feeling of being small but connected, the feeling of wonder that does not demand answers but delights in questions. These feelings will be our companions for the journey ahead, as we look more closely at the galaxy we call home, this vast spiral of stars that contains everything we have ever known, everything we have ever loved, everything we have ever been. The Milky Way awaits us. Its billions of suns are shining in the darkness, as they have shone for billions of years before us and will shine for billions of years after we are gone. But tonight, for these few precious hours, those suns are shining for us. They are the backdrop of our wondering, the stage on which our questions play out. And we are the audience, yes, but we are also the actors. We are the ones who ask, who wonder, who seek to understand. And that makes all the difference, so take a deep breath. Feel your body relaxing ever deeper into comfort, and let us continue our journey, drifting like light across the cosmic darkness toward the heart of everything we think we know. Let us turn our attention now to the galaxy that contains us, this magnificent spiral of stars that we have named the Milky Way. The name itself is ancient, reaching back to a time when our ancestors looked up at that pale band of light stretching across the night sky and imagined it as a river of milk spilled across the heavens by the gods. They could not have known, those early stargazers, that what they were seeing was the light of billions of suns, blended by distance into a soft, continuous glow. They could not have known that they were looking at their own galaxy from the inside, seeing it edge on because we were embedded within its disk. They could not have known that this river of light was also their home, the cosmic island on which their small blue planet drifted through the emptiness of space. But now we know, and the knowing has not diminished the wonder. If anything, it has amplified it beyond measure. Because the Milky Way, as we have come to understand it through centuries of careful observation and investigation, is far more magnificent than any myth could capture. It is a structure of almost incomprehensible scale and beauty, a swirling dance of matter and energy that has been playing out for billions of years and will continue for billions more. And tonight, as we contemplate the possibility that this galaxy might be only a single pixel in a much larger picture, I want us to first appreciate just how extraordinary this pixel truly is. Imagine, if you will, that you could somehow rise above the plane of the Milky Way, ascending through the layers of stars until you reached a vantage point from which you could see the entire galaxy spread out below you like a luminous flower floating in the darkness of space. What would you see from such a perspective? The answer, based on everything we have learned from our embedded position within the galaxy, is breathtaking. You would see a disk of stars roughly 100,000 light-years in diameter, spinning slowly around a central point. The disk would not be a simple flat shape, but a complex spiral, with great arms of stars and gas and dust sweeping outward from the center, like the arms of a cosmic pinwheel. There are at least 4 major spiral arms, and possibly more, each one a site of active star formation, each one glowing with the blue-white light of young, hot stars and the red warmth of stellar nurseries where new suns are being born from collapsing clouds of gas. Between the arms, older, cooler stars drift in more stable orbits, their yellow and orange light a testament to their ancient age, their patient endurance through billions of years of cosmic history. At the center of this great wheel of stars, you would see a bulge, a thick concentration of older stars crowded together in a spherical region that rises above and below the plane of the disk. This central bulge is one of the oldest parts of the galaxy, containing stars that formed in the early epochs of cosmic history, when the universe was still young and the elements that make up planets like Earth had not yet been forged in the hearts of dying suns. And at the very center of the bulge, hidden from direct view by thick clouds of dust but revealed to us through radio waves and X-rays, lies one of the most mysterious objects in the cosmos, a supermassive black hole, with a mass equivalent to 4 million suns, sitting quietly at the gravitational center of everything. This black hole, which we have named Sagittarius A after the constellation in which it appears, is a monster of gravity so intense that not even light can escape its grasp. And yet, for all its power, it is remarkably peaceful at the moment. It is not actively consuming matter, not flaring with the tremendous energy that characterizes the supermassive black holes at the centers of other galaxies. It is waiting, perhaps, for the next meal to fall within its reach. In the meantime, it anchors our galaxy, its gravity providing the central point around which everything else orbits. Let us think about that for a moment. The Sun, our local star, the source of all light and warmth and life on Earth, is orbiting this central black hole. Right now, as you listen to these words, you are traveling through space at an astonishing speed, carried along with the Sun on its 230 million-year journey around the galactic center. You have completed this journey before, many times, though not in your current form. The last time the Sun was at this point in its orbit, dinosaurs walked the Earth. The next time it returns to this point, whatever lives on Earth then will be as different from us as we are from those ancient creatures. The galaxy is old, you see. It has been spinning for a long, long time, and it will continue spinning for a long time to come. I want you to feel the motion of this, even though you cannot sense it in your daily life. Right now, you are moving. Not just with the rotation of the Earth, which carries you around at roughly 1,000 miles per hour at the equator. Not just with the orbit of the Earth around the Sun, which adds another 67,000 miles per hour to your cosmic velocity, but also with the motion of the entire solar system around the galactic center, which adds something like 500,000 miles per hour more. You are hurtling through space at incredible speed, even as you lie still and listen to these words, and you feel nothing, because there is nothing to feel. Space is smooth and empty, and motion through it is silent and serene. This is one of the strangest truths about our universe. We are moving incredibly fast, and yet we are completely at rest. There is no friction, no resistance, no sensation of motion. We are like passengers on a ship so smooth and steady that we cannot tell we are moving at all. And this ship, our galaxy, is carrying us through an ocean of emptiness toward destinations we cannot imagine, on a journey that will take hundreds of millions of years to complete. Now let us consider the stars themselves, the individual points of light that make up this great galactic ship. How many stars are there in the Milky Way? The current best estimate is around 200 billion to 400 billion stars, though this number is uncertain and may be revised as our observations improve. Let me try to help you feel the weight of that number, even though it is too large for any human mind to truly grasp. If you were to count one star per second, never stopping to rest, never pausing even for a breath, it would take you over 6,000 years to count to 200 billion. 6,000 years is longer than all of recorded human history. The pyramids of Egypt were built only about 4,500 years ago. The invention of writing was only about 5,000 years ago. If you had started counting at the dawn of human civilization, never stopping for a moment, you would still be counting today. And you would not be finished for another 1,000 years or more. And yet, this is only our galaxy. This is only the Milky Way. There are, as we discussed in the previous chapter, at least 2 trillion other galaxies in the observable universe, each with its own billions of stars. The numbers become almost meaningless at this scale, not because they are unreal, but because they exceed anything we can intuitively comprehend. We are not built for such magnitudes. Our minds evolved to handle dozens, perhaps hundreds of individual things. The concept of a billion is already beyond our direct experience. The concept of 2 trillion is simply beyond. But here is the thing that I find most remarkable about all of this. Despite the unimaginable number of stars in the Milky Way, Despite the vast gulfs of space between them, space is mostly empty. The average distance between stars in our part of the galaxy is about 4 light-years. That means if you shrank the Sun down to the size of a grain of sand, the nearest star, Proxima Centauri, would be another grain of sand roughly 4 miles away. The Milky Way is enormous, but it is also sparse. It is 100,000 light-years of mostly nothing, with occasional pinpricks of nuclear fire scattered through the void like fireflies in a vast dark meadow. This emptiness is important to understand because it helps us appreciate both the scale of the cosmos and its profound loneliness. When we think about traveling to other stars, we must confront the reality that the distances involved are almost beyond imagination. Even light, the fastest thing in the universe, takes more than 4 years to reach our nearest stellar neighbor. For a spacecraft, the journey would take far, far longer. Our current technology could reach Proxima Centauri in perhaps 70,000 years. That is longer than modern humans have existed. If we had launched a spacecraft toward Proxima Centauri when the first Homo sapiens appeared in Africa, it would still be traveling today, and it would still have tens of thousands of years to go. These distances define our existence. They place limits on what we can know, what we can explore, what we can become, and they remind us, in case we ever forget, just how precious and precarious our position really is. We live on a small planet, orbiting a small star, in a vast galaxy, in an even vaster universe, and the gulfs between the stars are so enormous that we may never cross them, no matter how long our species survives. But let us not dwell on limitations. Let us instead appreciate the beauty of what we have, the magnificence of the home we have been given by cosmic chance. Because the Milky Way, for all its emptiness, for all its vast uninhabited spaces, is a place of extraordinary wonder. Consider the variety of stars that make their home in our galaxy. There are red dwarfs, small and cool and long-lived, so faint that they are invisible to the naked eye even from a distance of just a few light-years. These are the most common stars in the galaxy, making up perhaps 70% of all stellar objects. They burn their nuclear fuel slowly and steadily, and they will continue to shine for trillions of years, long after the sun has died and faded into darkness. Some of them may harbour planets, and some of those planets may be warm enough for liquid water, that magic substance that seems to be necessary for life as we know it. We have already found evidence of such planets, rocky worlds orbiting in the habitable zones of red dwarf stars, and we wonder what kinds of life might exist there. In the dim red light of those ancient suns, there are yellow dwarfs like our sun, medium-sized stars that burn for roughly 10 billion years before expanding into red giants and then shedding their outer layers to become white dwarfs, dense stellar corpses that slowly cool over trillions of years. These stars are rare compared to red dwarfs, but they include our own dear sun, and so they hold a special place in our hearts. It was a yellow dwarf that gave us light and warmth and life. It was a yellow dwarf that made Earth possible. And it is a yellow dwarf that we see every morning rising in the east, reminding us that we are part of something larger than ourselves. There are giant stars, blue and hot and brilliant, burning through their nuclear fuel at prodigious rates and living for only a few million years before exploding in tremendous supernovae that scatter heavy elements across the galaxy. These stars are the cosmic forges that create the atoms of which we are made. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of these were created in the cores of stars that died before the sun was born. Every time you look at a bright blue star in the night sky, you are seeing a factory that is, at this very moment, creating the raw materials from which future planets and future life will be built. There are neutron stars, the compressed cores of dead suns, spinning hundreds of times per second and emitting beams of radiation that sweep across the cosmos like the lights of a cosmic lighthouse. These objects are so dense that a teaspoon of their material would weigh 1 billion tons on Earth. They represent matter in a state that defies ordinary understanding, compressed by gravity to densities that approach the theoretical limit of what matter can become before collapsing into a black hole. And speaking of black holes, there are many of them scattered throughout the galaxy, the remnants of the most massive stars that have died and collapsed under their own gravity. These objects represent the ultimate victory of gravity over matter, places where space-time itself is so curved that nothing can escape, not even light. They are invisible in the usual sense, detectable only by their effects on surrounding matter, but they are very real, and they may number in the hundreds of millions within the Milky Way alone. All of these stars, all of these stellar objects are part of the pixel we call home. They are the points of light that make up our galaxy, the building blocks of the structure that surrounds us. And each of them has its own story, its own history, its own contribution to the cosmic narrative. Each of them was born from a cloud of gas and dust, lived for millions or billions of years, and eventually died or will die, returning its material to the galaxy for future generations of stars to use. The galaxy is a great recycling system, constantly creating new stars from the ashes of the old, constantly evolving and changing even as its overall structure remains stable over billions of years. Now let us think about where we are within this vast structure. The Sun, our local star, is located in one of the spiral arms of the Milky Way, in a region that astronomers call the Orion Arm, or, sometimes, the Orion Spur. We are not at the center of the galaxy, where stars are crowded together in dense clusters, and the radiation from the supermassive black hole occasionally flares with tremendous energy. We are not at the edge of the galaxy, in the sparse regions where stars are few, and the darkness between them is almost absolute. We are somewhere in between, in a relatively quiet neighborhood, far from the most violent and energetic regions, but close enough to the action that we can observe it with our telescopes and wonder at its power. This location may not be a coincidence. Some scientists have speculated that the relative calm of our galactic neighborhood is one of the reasons life was able to evolve on Earth. In regions closer to the galactic center, the density of stars is so high that planetary systems may be constantly disrupted by gravitational encounters with passing suns. The radiation environment may be too harsh for complex life to develop. The frequency of supernovae may be too high, bathing planets in sterilizing radiation every few million years. Out here, in the relative suburbs of the galaxy, things are calmer. The stars are more widely spaced, the radiation is more manageable, and life, perhaps, has a better chance to take hold and flourish. Of course, we do not know for certain that this is why life arose on Earth. We do not know for certain that life has not arisen elsewhere, in the denser regions of the galaxy, adapting to conditions that would seem hostile to us. We do not know much, really, about how common life is in the universe or what forms it might take. But the speculation is interesting, and it reminds us that our existence may depend on factors far larger than we usually consider. We are not just products of our planet. We are products of our galaxy, our cosmic environment, our position in the grand structure of the Milky Way. I want you to imagine now that you are floating in space, somewhere above the plane of the galaxy, looking down at this magnificent structure. You can see the spiral arms glowing with the light of young stars. You can see the central bulge, warm and orange with the ancient light of old suns. You can see the dark lanes of dust that wind between the stars, blocking light in some places, creating the illusion of rifts and divisions in what is really a continuous structure. And somewhere, in one small region of one spiral arm, too small to see from this vantage point, is a yellow star with a family of planets, one of which is blue and green and wrapped in a thin layer of air. That is home. That is where you are even now, even as you imagine floating among the stars. You have never left that small blue world, and perhaps you never will. But in your mind, in your wonder, you can travel anywhere. You can see things that no human eye will ever see directly. You can know things that your ancestors never knew, and that, in itself, is a kind of miracle. As you drift in your imagination above the galaxy, I want you to notice something. The Milky Way, for all its size, for all its billions of stars, is finite. It has edges. It has a shape. It is not infinite. Beyond the edges of our galaxy, there is empty space, vast gulfs of nothing stretching away toward other galaxies, other islands of light in the cosmic ocean. The nearest large galaxy, Andromeda, is visible from our imagined vantage point, a smaller spiral of light some 2.5 million light-years away. It is moving toward us, drawn by gravity, and in about 4 billion years it will collide with the Milky Way, the two galaxies merging into a single larger structure. But for now it floats at a distance, a neighbor across an unimaginable void. And beyond Andromeda, there are more galaxies. Many more. The local group, as astronomers call it, contains about 80 galaxies, most of them small dwarf galaxies orbiting the larger spirals like satellites. Beyond the local group, there is the Virgo supercluster, containing thousands of galaxy groups and clusters spread across 100 million light-years of space. And beyond the Virgo supercluster, there are larger structures still, filaments and walls and voids that stretch across the observable universe, forming a cosmic web of matter that looks, from a sufficient distance, almost like the neurons of a vast brain. But we're getting ahead of ourselves. We will explore these larger structures in later chapters. For now, I want us to stay with our galaxy, to appreciate its beauty and its wonder, before we zoom out to consider the larger picture. Because if the Milky Way is a pixel, it is the most magnificent pixel we can imagine. It is the pixel that contains our Sun and our Earth and every human being who has ever lived. It is the pixel that gave rise to consciousness, to wonder, to the very capacity for asking the questions we are asking tonight. Whatever else may be true about the cosmos, this pixel matters. This pixel is precious. This pixel is home. Let us take a moment now to appreciate the history of our galaxy, the long cosmic story that brought us to this moment. The Milky Way is old, very old. Current estimates suggest that it formed roughly 13 billion years ago, not long after the Big Bang itself. In those early epochs, the universe was a hot, dense soup of particles and radiation, slowly cooling and expanding and allowing matter to clump together under the influence of gravity. The first stars formed from this primordial matter, huge and hot and short-lived, burning through their fuel in just a few million years before exploding and scattering heavier elements into the void. These early supernovae seeded the young cosmos with the raw materials for later generations of stars, stars that would be smaller and longer-lived, stars that could have planets, stars like our Sun. The Milky Way grew through a combination of processes. Some stars formed from gas clouds within the galaxy itself, new generations rising from the ashes of the old. Other stars were captured from smaller galaxies that fell into the gravitational embrace of the Milky Way and were absorbed, their suns becoming part of our galactic population. The galaxy has consumed many smaller galaxies over its long history, and the process continues today. Even now, small dwarf galaxies are orbiting the Milky Way, slowly being torn apart by tidal forces, their stars being added to our own. The Sagittarius dwarf galaxy, for example, is currently passing through the disk of the Milky Way, leaving a trail of stars behind it as it is gradually absorbed. This history of consumption and growth is written in the motions and compositions of the stars around us. By studying the orbits and chemical makeup of different stellar populations, astronomers can piece together the history of our galaxy, identifying the remnants of ancient galaxies that were absorbed long ago, tracing the evolution of stellar populations from the early universe to the present day. It is a detective story written in starlight, and we're only beginning to read it. And the story continues. The Milky Way will not remain as it is today. In about 4 billion years, as I mentioned earlier, it will collide with Andromeda, and the two galaxies will merge into a single, larger structure. The collision will not be violent in the way we usually think of collisions. The stars are so far apart that almost none of them will actually hit each other. Instead, the gravitational dance of the two galaxies will disrupt their spiral structures, flinging stars into new orbits, triggering bursts of star formation as clouds of gas collide and compress, eventually settling into a new configuration, probably an elliptical galaxy without the beautiful spiral arms we see today. If any descendants of humanity are still around to see this cosmic event, they will witness something extraordinary. The night sky will change dramatically as stars from Andromeda intermingle with stars from the Milky Way. New constellations will form. The familiar patterns that humans have watched for thousands of years will dissolve into new arrangements, and the galaxy they call home will have a new name. Or perhaps no name at all, just another island of light in an even more ancient cosmos. But that is far in the future. Tonight the Milky Way is still a beautiful spiral, still spinning slowly through the darkness, still home to hundreds of billions of stars and perhaps countless planets. Tonight we can appreciate it as it is, a magnificent structure that has taken billions of years to form and will continue to evolve for billions more. Tonight we can wonder at its beauty and feel grateful for our place within it. Let me share one more perspective on our galactic home before we move on. Everything I have described, the billions of stars, the spiral arms, the central black hole, the vast distances between suns, all of this is just the visible matter. It is just the stuff that we can see, the stuff that emits or reflects light. But there is far more to the Milky Way than meets the eye or any telescope. The galaxy is embedded in a vast halo of dark matter, a mysterious substance that does not emit or absorb light, but makes its presence known through its gravitational effects. We cannot see dark matter directly. We have not yet identified what it is made of, despite decades of searching. But we know it is there because of the way stars move within galaxies. Without the extra gravity provided by dark matter, stars in the outer reaches of the Milky Way would be moving too fast to remain bound to the galaxy. They would fly off into intergalactic space. The fact that they do not, the fact that they remain in stable orbits, tells us that there is far more mass in the galaxy than we can see. Current estimates suggest that the Milky Way's dark matter halo extends far beyond the visible disk of stars, forming a vast sphere that may be 1 million light-years in diameter. Most of the galaxy's mass is in this invisible halo, not in the stars and gas and dust that we can observe. We are, in a sense, living in a sea of dark matter, swimming through a medium that we cannot see but that holds us in its gravitational embrace. This is one of the great mysteries of modern cosmology. What is dark matter? Where did it come from? Why does it interact so weakly with ordinary matter that we cannot detect it directly? These questions remain unanswered, and they remind us how much we still do not understand about the universe we live in. For all our knowledge, for all our technological sophistication, there are vast realms of ignorance that we have only begun to explore. And perhaps that is fitting tonight. Perhaps the existence of dark matter is a metaphor for our situation more broadly. We see only a small fraction of what exists. We understand only a small fraction of what we see. And beyond the edges of our understanding, there is more, always more, waiting to be discovered, waiting to be wondered at. As we conclude this chapter and prepare to move on to deeper contemplations, I want you to carry with you a sense of our galaxy as a place of extraordinary beauty and mystery. The Milky Way is not just a backdrop for our existence. It is an active participant in our story, a living structure that is constantly changing and evolving, that gave us the elements from which we are made, that provides the stage on which the drama of life plays out. It is home, in the deepest sense of that word, the only home our species has ever known. And yet, as we will explore in the chapters ahead, this home may be far smaller than it appears. The galaxy that seems so vast, so all-encompassing, may be only a tiny fragment of a much larger whole. The pixel we call home may be one of countless pixels in a picture so vast that we cannot perceive its edges, a picture so complex that we cannot guess its subject. But for now, rest here. In the warmth of our galactic home, feel the light of 400 billion stars wrapping around you like a blanket of fire and ice. Know that you are part of this, that you belong here, that the atoms in your body were forged in the hearts of these suns and will return to the galaxy when you are gone. You are a child of the Milky Way, a temporary gathering of stardust that has somehow become aware of itself. And that is wonderful. That is enough. That is everything. Let your breathing slow. Let your thoughts drift like stars through the darkness. The galaxy holds you. The cosmos holds you. And in this moment, in this quiet hour, there is nothing you need to do except exist and wonder and rest. The journey continues, the next chapter awaits, but there is no hurry. There is never any hurry here among the stars. Take all the time you need. The Milky Way will still be spinning when you wake. The cosmos will still be wondering at itself through your eyes. And we will still be here, together, drifting through the infinite night. Let us step back now from the cosmic immensity we have been contemplating and consider something much smaller, something almost mundane, something so familiar that you probably never think about it at all. Let us consider a photograph. Not a photograph of anything in particular, just the idea of a photograph, a captured moment of light frozen in time, a rectangle of color and form that represents something real, but is not, itself, the real thing. This simple, everyday object holds the key to understanding the question at the heart of our journey tonight. The question of whether our galaxy might be only a single pixel in a much larger cosmic picture. You have seen countless photographs in your life. Perhaps you have a few favorites, images that capture moments you cherish, faces of people you love, places that hold special meaning for you. When you look at these photographs, you see the subjects they depict. You see the smile, the sunset, the mountain, the child at play. You do not see the photograph itself, the physical or digital medium that carries the image. Your eyes and brain work together to look through the medium and perceive what it represents. But now, imagine taking one of these photographs and zooming in on it, closer and closer until the smooth curves and continuous colors begin to dissolve into something unexpected. If the photograph is printed on paper, you might start to see the individual dots of ink, the tiny circles of cyan and magenta and yellow and black that, from a distance, blend together to create the illusion of continuous color. If the photograph is displayed on a screen, you might start to see the pixels, those tiny squares of red and green and blue light that, from a distance, merge into the colors of the rainbow. This is the fundamental truth about images. They're made of discrete parts. What appears continuous is actually composed of countless tiny elements, each one simple and individual, each one contributing its small piece to the larger whole. A photograph of a sunset is not truly a sunset. It is an arrangement of dots or pixels that, when viewed from the right distance, creates the impression of a sunset in the mind of the viewer. The magic of images lies in this illusion, this ability of our brains to assemble discrete elements into meaningful wholes. And here is where the metaphor begins to connect to our cosmic contemplations. What if the universe works the same way? What if what we perceive as the continuous fabric of space and time is actually composed of discrete elements, too small for us to see, too fundamental for us to perceive directly? What if our entire galaxy, vast and beautiful and complex as it is just one of these elements, one pixel in a cosmic image that we cannot step back far enough to see? This is not just idle speculation. The question of whether space and time are continuous or discrete is one of the deepest questions in physics. At the scales we can observe directly, space and time certainly appear continuous. You can divide a meter into centimeters, millimeters, micrometers, nanometers, and so on, apparently forever. You can divide a second into milliseconds, microseconds, nanoseconds, picoseconds, and so on, apparently without limit. There seems to be no smallest unit of distance or time, no fundamental pixel of space-time that cannot be subdivided further. And yet, some theories suggest otherwise. At the very smallest scales, far below what any experiment can currently probe, space and time may break down into something granular, something discrete, something like pixels. The Planck length, roughly 1.6 times 10 to the negative 35 meters, is often cited as the scale at which quantum effects and gravitational effects become equally important, the scale at which our current understanding of physics breaks down. Some physicists have speculated that this might be the fundamental pixel size of space itself, the smallest distance that has any meaning. If this is true, then space is not a smooth continuum, but a kind of lattice, a grid of the tiniest possible cells, each one a single unit of distance that cannot be further divided. And time, similarly, would flow not smoothly but in discrete jumps, each tick of the cosmic clock moving the universe forward by one Planck time, roughly 5.4 times 10 to the negative 44 seconds. These numbers are so small as to be almost meaningless to our everyday experience. The Planck length is so tiny that the observable universe is roughly 10 to the 60 Planck lengths across. If the Planck length were the size of a grain of sand, the observable universe would be vastly, enormously, incomprehensibly larger than anything we could visualize. And yet, if this picture is correct, then at the very bottom of reality, at the most fundamental level, space and time are made of discrete units. Reality is, in some sense, pixelated. But this is not quite the metaphor I want to develop tonight. The pixels we have been imagining, the ones that might make up the fundamental fabric of space-time, are unimaginably small. They are the opposite of the cosmic pixels we have been contemplating when we wonder whether our galaxy might be a single point in a larger picture. The Planck scale pixels are at the bottom of reality, the smallest possible units. The cosmic pixels, if they exist, would be at the top of reality, the larger structures that form the elements of something even larger. So let us leave aside the physics of the very small and return to our metaphor of photographs and images. When you look at a photograph on a screen, each pixel is a point of light that contributes to the overall image. From close up, you can see the individual pixels, and the image dissolves into a mosaic of colored squares. From far away, the pixels merge into a coherent picture, and you see the subject rather than the medium. The distance from which you view the image determines what you perceive. Stand too close, and you see only pixels, meaningless in isolation. Stand too far, and the image becomes too small to make out, just a dot of light among other dots. There is an optimal viewing distance, a sweet spot where the individual elements blend into a coherent whole, and the full beauty of the image becomes apparent. Now imagine that you are a conscious being living inside one of those pixels. From your perspective, within the pixel, you cannot see the larger image at all. You know only your own pixel, your own local region of color and light. Perhaps you can observe the edge of your pixel, the boundary where your world ends and other worlds begin. Perhaps you can even communicate with neighboring pixels, exchanging information about the colors and patterns that characterize your respective regions. But you cannot step back and see the larger picture. You cannot perceive the sunset or the smile or the mountain that the pixels collectively form. You are trapped within your local perspective, unable to access the global view. This is our situation, metaphorically speaking. We live within the Milky Way, our local pixel in the cosmic image. We can observe our galaxy in great detail. We have mapped its structure, counted its stars, measured its size and shape and motion. We can see beyond our galaxy to other galaxies, other pixels in the cosmic picture. We have catalogued millions of them, photographed them, studied their properties. But we cannot step back far enough to see the larger pattern that these galaxies might form. We are inside the image, looking out at our immediate neighbors, unable to perceive the global structure that might give meaning to our local observations. What might that larger picture look like? This is where our imagination must take over, because we have no way of knowing for certain. The observable universe, with its trillions of galaxies, is already so vast that our minds cannot truly comprehend it. If there is a larger picture of which this is only a fragment, it would be vaster still, perhaps infinitely vast, extending forever in all directions, containing structures so large that our entire observable universe would be invisible within them. Let me try to paint a picture for you, knowing that any picture I paint will be inadequate to the reality, if such a reality exists. Imagine that each galaxy in the observable universe is a pixel, a point of light in a cosmic image. The colors of these pixels vary. Some galaxies are blue, dominated by young, hot stars. Some are red, populated by older, cooler suns. Some are mixtures, swirls of color that represent the complex interplay of stellar populations within each galactic structure. Now imagine that these pixels, these galaxies, form patterns when viewed from a sufficient distance. Perhaps they cluster together to form shapes, cosmic forms that we cannot perceive from our embedded position. Perhaps they trace outlines of structures we cannot imagine, structures as far beyond our comprehension as a sunset is beyond the comprehension of a single pixel. Perhaps the entire observable universe, with its 2 trillion galaxies, is like a tiny patch of a much larger image, a small region of color that contributes to something we cannot see. What might that something be? Some physicists have speculated about the possibility of a multiverse, a vast ensemble of universes of which our own is only one. In some versions of this idea, the multiverse is infinite, containing an endless number of universes with different physical laws, different constants of nature, different outcomes for the random processes that shape cosmic evolution. If the multiverse exists, our universe might indeed be a pixel, a single frame in an infinite gallery of cosmic images. Other physicists have speculated about higher dimensions, realms of existence that extend beyond the 3 dimensions of space and 1 dimension of time that we can perceive directly. If higher dimensions exist, then what we perceive as our 3-dimensional universe might be a kind of shadow or projection of something more complex, a slice through a higher dimensional reality that we cannot fully access or understand. From the perspective of a higher dimensional observer, if such an observer could exist, our universe might appear very different, might form patterns and structures that are invisible to us. These ideas are speculative, of course. They are not established science, but rather possibilities suggested by our current theories, possibilities that we cannot yet test or verify. But they remind us that the universe may be far larger and far stranger than anything we have directly observed. They remind us that what we call reality may be only a small fragment of a much greater whole. And this is where the metaphor of pixels becomes most powerful. A single pixel, in isolation, is meaningless. It is just a point of color, a square of light. It has no significance, no purpose, no beauty on its own. But in combination with other pixels, it becomes part of something meaningful. It contributes to a pattern, a form, an image that has significance and beauty and meaning. If our galaxy is a pixel in a larger picture, then we are not alone. We are not isolated. We are connected through our position in the cosmic image to something far larger than ourselves. Our existence, small as it is, contributes to the whole. Our light, faint as it is, adds to the cosmic pattern. We matter, not because we are the center of the universe, but because we are part of it, a necessary element in the grand design. I want you to sit with that idea for a moment. Let it settle into you like starlight filtering through dark clouds. You are part of something larger. Your life, your thoughts, your very existence is a contribution to the cosmic whole. You're not separate from the universe. You are an expression of it. You are the universe, in one small and temporary form, wondering about its own nature. This is the deepest truth of the pixel metaphor. It is not just about size and scale. It is about connection and meaning. It is about recognizing that what seems isolated and insignificant from one perspective might be essential and beautiful from another. It is about humility, yes, but also about belonging. We are small, but we belong to something vast. We are temporary, but we are part of something eternal. We are pixels, and together we form a picture whose beauty we cannot see but can perhaps, in our best moments, begin to imagine. Let us now consider what happens when we change the resolution of an image. In digital photography, resolution refers to the number of pixels that make up the image. A high-resolution image has many pixels, allowing for great detail and sharpness. A low-resolution image has fewer pixels, resulting in a coarser, more blurry appearance. When you decrease the resolution of an image, you lose detail. Features that were visible in the high-resolution version become blurred or invisible. Colors blend together. Fine distinctions are lost. What remains is a simplified version of the original, a representation that captures the broad strokes but misses the subtleties. Now consider this. What if our perception of the universe is like a low-resolution image? What if there are details, structures, patterns that exist at scales or in dimensions that we cannot perceive, that are invisible to our telescopes and instruments, that lie beyond the limits of our observation? We might be seeing a simplified version of reality, a cosmic image that has been reduced, by the limitations of our position and our senses, to something coarser and less detailed than what actually exists. This is not as fanciful as it might sound. Our senses are limited by biology and by the laws of physics. We can see only a narrow band of the electromagnetic spectrum, the range of light that our eyes evolved to detect. Beyond this band, there is radio light and infrared light, and ultraviolet light and X-rays and gamma rays, all forms of electromagnetic radiation that are invisible to our unaided eyes. We have built instruments to detect these forms of light, and they have revealed a universe far richer and more complex than what we can see with our eyes alone. But even our instruments have limits. There are surely forms of radiation, forms of matter, forms of existence that lie beyond what any instrument can currently detect. Dark matter, as we discussed earlier, is invisible to all our telescopes, detectable only through its gravitational effects. Dark energy, the mysterious force that seems to be accelerating the expansion of the universe, is even more mysterious, a property of space itself that we have only begun to understand. These invisible components make up the vast majority of the cosmos, and we know almost nothing about them. What else might be invisible to us? What other aspects of reality might we be missing? Might be beyond our current resolution, might become visible only when we develop new instruments, new theories, new ways of perceiving the cosmos? We cannot know, of course. The limits of our knowledge are, by definition, invisible to us. But we can wonder, we can imagine, we can hold open the possibility that reality is far more complex and far more beautiful than anything we have yet perceived. And this brings us back to our central question. What if the Milky Way is only a single pixel in a larger picture? If this is true, then we are looking at the universe at very low resolution indeed. We are seeing only the broadest strokes, the most basic elements, the simplest version of what exists. The details, the patterns, the the full complexity of the cosmic image would be invisible to us, beyond our ability to perceive or understand. But here is the remarkable thing. Even at this low resolution, the universe is staggeringly beautiful. Even with our limited perceptions, we have discovered wonders beyond counting. We have seen galaxies colliding in slow motion, their arms tangling like dancers in an embrace. We have seen stars being born in glowing clouds of gas and dust, igniting with the fire of nuclear fusion, beginning their long journey through the stellar life cycle. We have seen the remnants of ancient explosions, nebulae painted in colors that no human eye has evolved to see, captured by our instruments and translated into images of heartbreaking beauty. If this is what we can see at low resolution, what might be visible at higher resolution? What patterns, what structures, what beauties might reveal themselves if we could only step back far enough, see deeply enough, perceive clearly enough? The imagination staggers at the possibilities, and perhaps that is the point. Perhaps the universe is designed, if that is the right word, to always exceed our imagination, to always offer more than we can perceive, to always remain mysterious and wonderful no matter how much we learn. Let me offer one more aspect of the pixel metaphor before we move on. In a digital image, each pixel is assigned a specific color, a specific value that determines how it appears in the final picture. But the color of a pixel does not exist in isolation. It derives its meaning from its context, from its relationship to the other pixels around it. A red pixel might be part of a rose, or part of a sunset, or part of a fire, depending on what surrounds it. The meaning of the pixel is not intrinsic to the pixel itself. It is relational, contextual, dependent on the larger pattern. Similarly, the meaning of our galaxy, if the Milky Way is a pixel, would not be intrinsic to the galaxy itself. It would be relational, dependent on the larger pattern of which we are a part. We might be part of a cosmic flower, or a cosmic face, or a cosmic abstraction beyond anything we can imagine. We cannot know from inside the pixel what role we play in the larger picture. We can only trust that we have a role, that our existence contributes something, that the cosmic artist, whoever or whatever that might be, placed us here for a reason. This is a kind of faith, I suppose, a cosmic faith that goes beyond what science can prove or disprove. Science can tell us about the physical structure of the universe, about the distribution of galaxies and the properties of matter. But science cannot tell us about meaning, about purpose, about the significance of our existence in the grand scheme of things. These are questions for philosophy, for theology, for poetry, for the quiet contemplation of a sleepless night. And perhaps that is fitting. Perhaps there are questions that science can answer and questions that it cannot, and the distinction between them is one of the most important things we can understand. We need science to tell us what the universe is. We need other ways of knowing to help us understand what the universe means. Tonight, as we drift through these contemplations, we are engaging in both kinds of inquiry. We are exploring what science has revealed about the cosmic structures that surround us, and we are also wondering about the meaning of these structures, about our place within them, about the significance of being a conscious pixel in a possibly infinite cosmic image. Both kinds of inquiry are valid, both kinds are necessary, and both kinds can bring us closer to the truth of our situation, the strange and wonderful truth of being small, conscious creatures in a vast, mysterious universe. Let us pause here for a moment and let these ideas settle. The metaphor of pixels and resolution is simple, but its implications are profound. We are, perhaps, like pixels in an image we cannot see. We are perhaps seeing the universe at low resolution, missing details and patterns that lie beyond our perception. We are perhaps part of something meaningful and beautiful, contributing to a cosmic picture whose subject we cannot guess. And in the face of all this uncertainty, all this mystery, all this vastness, we are here, we are conscious, we are wondering. That, in itself, is remarkable. That in itself might be the most remarkable thing of all, so breathe deeply. Let your body relax ever further into comfort. Let your mind drift like a pixel floating in a cosmic image, at home in the vast pattern, part of something larger than yourself. The journey continues, the mystery deepens, and we are together in it, you and I, wondering at the beauty of all that is. The resolution of the cosmic image is unknown. Perhaps it is infinite, with details nested within details forever. Perhaps it is finite, with some ultimate pixelation at the bottom or the top or somewhere in between. Perhaps the very concept of resolution does not apply to the cosmos in the way it applies to photographs, and we are stretching the metaphor beyond its useful limits. But metaphors do not need to be perfect to be useful. They need only to illuminate, to suggest, to open doors in our minds that were previously closed. And the metaphor of pixels and resolution has opened many doors tonight. It has helped us see our galaxy in a new way, as a possible element in a larger pattern. It has helped us appreciate the limits of our perception and the vast realms that might lie beyond those limits. It has helped us feel our connection to something larger than ourselves, our place in a cosmic picture that we cannot step back far enough to see. As we prepare to move into deeper contemplations, to explore the limits of the observable universe and what might lie beyond, carry this metaphor with you. Think of yourself as a conscious being living within a pixel, aware of your local environment, curious about the larger picture, able to wonder even if you cannot know. This is the human condition, cosmically speaking. We are embedded in the image. We cannot step outside it. But we can imagine, we can wonder, we can dream of what the full picture might look like, and in that dreaming, we touch something true. The pixels blur together in the cosmic night. The galaxies spin in their ancient dances, and somewhere in the vast pattern, on a small planet orbiting a medium star in one arm of a spiral galaxy, a conscious being drifts towards sleep, wondering at the beauty of it all. This is where we are. This is who we are. And this is enough. More than enough. This is everything. The chapter ends, but the story continues. The resolution of the cosmic image remains unknown. The larger picture remains unseen. But we are here, pixels in the infinite mosaic, wondering and dreaming and reaching toward understanding. And in that reaching, we are beautiful. In that wondering, we are meaningful. In that dreaming, we are part of something vast and eternal, something that was here before us and will be here after we are gone. Rest now, gentle pixel. Rest in the knowledge that you are part of something larger. Rest in the wonder of your own existence. The cosmos holds you in its patterns. The image contains you in its design. And whatever the picture may be, your light contributes to its beauty. Sleep approaches like a gradient, like the soft blur between pixels, like the gentle fading of one color into another. Let it come. Let it wash over you like cosmic background radiation, that ancient light from the beginning of time, still filling the universe with its soft, warm glow. You are home. You are held. You are part of the picture. And the picture, whatever it may be, is beautiful. And so we continue our journey together, drifting ever deeper into the cosmic night, carried by curiosity and wonder toward the edges of what can be known. You have rested, perhaps, in the gentle pause between chapters, letting the ideas we have explored settle into your mind like sediment, drifting slowly to the bottom of a still pond. The Milky Way still spins around us, its hundreds of billions of stars tracing their ancient paths through the darkness. The metaphor of pixels still holds us, reminding us that we might be part of something larger than we can perceive. And now, as we prepare to venture further, I want to take you to the very edge of the observable universe, to the boundary beyond which even light cannot reach us, to the cosmic horizon that defines the limits of everything we can ever hope to see. There is something both humbling and exhilarating about contemplating limits. We humans have always pushed against boundaries, always sought to see what lies beyond the next hill, the next ocean, the next frontier. This impulse has taken us from the African savanna to every corner of our planet, from the surface of our world to the depths of the ocean and the heights of the atmosphere, from our small blue marble to the dusty surface of the moon. We are a species that does not accept limits easily, that sees every boundary as a challenge to be overcome, every horizon as an invitation to explore. But the observable universe presents us with a different kind of limit, a boundary that we cannot overcome no matter how advanced our technology becomes, no matter how clever our methods, no matter how long our species survives. This is a limit imposed not by our capabilities, but by the fundamental structure of reality itself, by the finite speed of light and the finite age of the cosmos. And understanding this limit is essential to grasping the full wonder of our situation. the strange and beautiful position we occupy as conscious beings, peering out into an infinity we cannot fully perceive. Let me explain what we mean by the observable universe. When we look out into space, we are also looking back in time. This is one of the most remarkable facts about astronomy, a consequence of the finite speed of light that transforms every telescope into a kind of time machine. The light from the sun takes about 8 minutes to reach Earth, so when you look at the sun, you're seeing it as it was 8 minutes ago. The light from the nearest star, Proxima Centauri, takes about 4 years to reach us, so when we observe that star, we are seeing it as it was 4 years in the past. The light from the Andromeda galaxy takes about 2.5 million years to reach us, so the Andromeda we see in our telescopes is Andromeda, as it existed when our ancestors were still learning to walk upright on the African plains. As we look at more and more distant objects, we are looking further and further back in time. The most distant galaxies we can observe are so far away that their light has been travelling for over 13 billion years, since not long after the Big Bang itself. When we observe these galaxies, we're seeing them as they were in the early epochs of cosmic history, when the universe was young and hot and filled with the raw materials from which all later structures would form. But here is the crucial point. There is a limit to how far back we can see. The universe is approximately 13.8 billion years old. Light travels at a finite speed. Therefore, there is a maximum distance from which light could have reached us since the beginning of time. Beyond that distance, the light simply has not had enough time to travel to our location. It is still on its way, crossing the vast gulfs of space, carrying its message toward a destination it will not reach for billions of years to come. This maximum distance defines what we call the observable universe. It is the region of space from which light has had time to reach us since the Big Bang. Everything within this region is, in principle, observable. Everything beyond it is not and never will be, no matter how long we wait or how powerful our telescopes become. The size of the observable universe is staggering. The most distant light we can detect, the cosmic microwave background radiation left over from the early universe, was emitted about 13.8 billion years ago. But because the universe has been expanding all this time, the objects that emitted that light are now much farther away than 13.8 billion light-years. Current calculations suggest that the radius of the observable universe is about 46 billion light-years, meaning the entire observable universe is about 93 billion light-years in diameter. Let me try to help you feel the weight of that number, even though I know it will slip through your fingers like water, like starlight, like all the cosmic quantities that exceed our intuitive grasp. 93 billion light-years. That means a beam of light, travelling at over 600 million miles per hour, would take 93 billion years to cross from one side of the observable universe to the other. If the sun were the size of a grain of sand, the nearest star would be about 4 miles away, and the observable universe would be larger than the actual distance between the sun and the nearest real star, scaled up by a factor of millions upon millions upon millions. Within this observable universe, there are approximately 2 trillion galaxies. Each of these galaxies contains, on average, something like 100 billion stars. That means there are roughly 200 sextillion stars in the observable universe, a 2 followed by 23 zeros. If you tried to count these stars at a rate of 1 per second, it would take you over 6 trillion years. Roughly 400 times the current age of the universe. The numbers become meaningless at this scale, not because they are untrue, but because they exceed anything our minds can genuinely comprehend. And yet, for all its staggering immensity, the observable universe may be only a tiny fraction of the total universe. This is the key insight I want us to hold tonight, the idea that keeps us company as we drift toward the edges of the known. What we can see is limited by the speed of light in the age of the cosmos. What exists may be far, far larger. Think of it this way. Imagine you're standing in the middle of a vast plain, shrouded in fog that limits your visibility to 100 meters in every direction. You can see everything within that 100-meter circle clearly enough. You can count the trees, observe the wildlife, study the terrain, but you have no way of knowing how far the plain extends beyond the fog. It might extend for another 100 meters. It might extend for 1,000 kilometers. It might extend forever, stretching without end in all directions, a plain of infinite extent of which your visible circle is the merest speck. This is our situation with respect to the universe. The observable universe is our circle of visibility, our region of clarity within the cosmic fog. We can see everything within it, study its structures, count its galaxies. But we have no way of knowing how far the universe extends beyond the observable portion. The fog in this case is not made of water droplets but of time itself, the finite amount of time that has passed since the beginning of the cosmos, limiting how far light can have travelled to reach our eyes. Some physicists believe that the universe extends far beyond the observable portion, perhaps infinitely far. If the universe is spatially infinite, as some models of cosmology suggest, then it contains not just 2 trillion galaxies but an infinite number of them, stretching forever in all directions, never ending, never reaching a boundary or an edge. The observable universe, in this scenario, would be like a single drop of water in an infinite ocean, a speck of clarity in an eternal expanse of existence. Other physicists believe that the universe may be finite but unbounded, like the surface of a sphere. If you walk in a straight line on the surface of a sphere, you never reach an edge, but eventually you return to your starting point. Similarly, the universe might be shaped in such a way that space curves back on itself, finite in volume but without any boundary. In this scenario, if you could travel far enough in any direction, you would eventually return to where you started, having circumnavigated the cosmos. We do not know which of these scenarios is correct. Our observations are consistent with a universe that is either infinite or very, very large, but we cannot distinguish between these possibilities with current technology. The curvature of space, if it exists, is too slight for us to measure. The universe appears flat, extending without apparent limit in all directions, but this flatness could be consistent with either a truly infinite cosmos or a finite cosmos so large that its curvature is imperceptible. And here is where our question about pixels becomes particularly poignant. If the universe is indeed infinite, then our galaxy, our Milky Way, is not just small, it is infinitesimally small, a single point in an endless expanse, a pixel in a picture of infinite resolution, contributing to a pattern that extends forever, without repetition or end. Infinity is a concept that the human mind grasps only imperfectly. We can define it mathematically, manipulate it symbolically, but we cannot truly imagine it. When we try to picture an infinite universe, we inevitably end up picturing a very large but finite universe, a universe with edges somewhere beyond our vision. True infinity escapes our intuition entirely, slipping away every time we try to hold it in our minds. And yet, the universe may be infinite. The cosmos may extend forever, and if it does, then the question we're asking tonight takes on a new significance. If the Milky Way is a pixel in an infinite picture, then there are infinitely many other pixels, infinitely many other galaxies, each one as real and as significant as our own. The pattern that these pixels form would not be a finite image, but an infinite one, a cosmic artwork of boundless extent and complexity. What might such an infinite pattern look like? We cannot know, of course. We cannot see beyond the observable universe, cannot perceive the structures that might exist in the vast regions beyond our cosmic horizon. But we can imagine, we can speculate, we can wonder about the forms and shapes and meanings that might be encoded in the infinite fabric of reality. Some physicists have speculated about cosmic structures that dwarf anything we can observe. If the universe is sufficiently large, then there might be regions where galaxies cluster together in patterns different from what we see in our local neighborhood. There might be vast voids, regions of space where matter is sparse and darkness reigns. There might be cosmic filaments, threads of galaxies stretching across billions of light years, forming a web of matter that pervades the universe at the largest scales. Indeed, we can see hints of such structures in the observable universe. The galaxies we observe are not distributed randomly but are clustered into groups and clusters and superclusters, connected by filaments of matter and separated by great voids where few galaxies exist. This cosmic web is the largest structure we can observe, a network of matter that pervades the observable universe and presumably extends beyond it into the unobservable regions. But the cosmic web we can see is only the local portion of a much larger structure. Beyond the observable universe, the web presumably continues, connecting galaxies and clusters we will never see, forming patterns we will never perceive. And if the universe is truly infinite, then the web extends forever, an infinite network of matter, stretching without end through the cosmic darkness. Let us pause here and breathe. Let the enormity of these ideas wash over you like a gentle wave. Not overwhelming but embracing, not frightening but comforting in its vastness. We are small, the universe is large, and yet here we are, conscious and wondering, able to contemplate infinities that exceed our comprehension. There is something remarkable about that, something almost miraculous. I want to share with you one of the most beautiful ideas to emerge from modern cosmology, an idea that illuminates the strangeness of our situation and the mystery of the cosmic horizon. It is the idea that the observable universe is growing moment by moment as light from ever more distant regions finally reaches our location. You see, the cosmic horizon is not static. It is expanding. As time passes, light from regions that were previously beyond our horizon has more time to travel, and gradually those regions come into view. The observable universe is therefore getting larger, not because space itself is expanding faster than light, but because more and more of the universe is becoming observable as light from distant regions finally completes its long journey to our eyes. Every second, new portions of the cosmos are coming into view for the first time. Light that has been traveling since the beginning of time is finally arriving at Earth, bringing with it information about galaxies and structures that no human eye has ever seen. The cosmic horizon is like a slowly expanding bubble, revealing more and more of the universe as it grows. This is a beautiful thought, but it is also bittersweet, because at the same time that new regions are coming into view, other regions are slipping beyond the horizon, never to be seen again. The universe is not only expanding but accelerating in its expansion, driven by the mysterious force we call dark energy. This acceleration means that distant galaxies are receding from us faster and faster, and eventually they will be receding faster than light itself. When a galaxy recedes faster than light, it crosses a threshold from which there is no return. Light from that galaxy will never again reach us, no matter how long we wait. The galaxy will fade from view, becoming dimmer and dimmer as its light is stretched by the expansion of space, eventually disappearing from the observable universe entirely. In the far future, trillions of years from now, nearly all the galaxies we can currently see will have crossed this threshold, leaving our descendants in a universe that appears empty, a small island of light in an infinite darkness. This is not a cause for alarm tonight. The timescales involved are so vast that countless generations will live and die before this cosmic loneliness sets in. But it is a reminder that the observable universe is not fixed, not eternal, but a transient window onto a much larger reality. What we can see today is different from what our distant ancestors could see, and different from what our distant descendants will see. The cosmos is in motion, always changing, always revealing new mysteries while concealing others. And here is the deepest mystery of all. Beyond the cosmic horizon, what exists? What galaxies spin in the darkness we will never see? What stars burn with fire that will never warm our skies? What forms of matter? What configurations of energy? What possibilities for life and consciousness might exist in the vast regions beyond our perception? We cannot know. We will never know. The cosmic horizon is a fundamental limit, not a technological one. No matter how advanced our telescopes become, no matter how clever our methods, we cannot observe what lies beyond the horizon because the light from those regions has not had time to reach us, and in many cases never will. This is a strange kind of ignorance, different from the ignorance we can hope to overcome through research and discovery. It is a permanent ignorance, built into the structure of reality itself. The universe contains secrets that it will never share with us, mysteries that we will never solve, questions that we will never answer, and perhaps that is as it should be. Perhaps a universe that revealed all its secrets would be less beautiful, less wondrous, less worthy of our contemplation. Perhaps the mystery is part of the gift. Let us turn now to what we can observe, to the structures that exist within the cosmic horizon, the patterns of matter and energy that we can study and begin to understand. The observable universe is not homogeneous. It is not a smooth, uniform distribution of matter. It is structured, organized, hierarchical, with patterns repeating at different scales like a cosmic fractal. At the smallest scale, there are stars, individual balls of nuclear fire burning in the darkness. These stars are grouped into galaxies, great islands of stars held together by gravity and orbiting around common centers. The galaxies themselves are grouped into clusters, collections of galaxies bound together by mutual gravitational attraction. And the clusters are connected by filaments, long threads of matter that stretch between them, forming a cosmic web that pervades the observable universe. The largest structures we can identify are superclusters, vast regions containing thousands of galaxies and spanning hundreds of millions of light years. Our own galaxy, the Milky Way, is part of the Virgo supercluster, which in turn is part of an even larger structure called Laniakea, a supercluster of superclusters containing about 100,000 galaxies spread across 500 million light-years. These structures are staggeringly large, far beyond anything our intuition can grasp, and yet they are still dwarfed by the observable universe as a whole, which is roughly 200 times larger than Laniakea in diameter. The cosmic web is the largest pattern we can perceive, but it is only a local portion of whatever larger pattern might exist beyond our horizon. If the Milky Way is a pixel, then the Virgo supercluster is perhaps a small patch of pixels, a local region of the cosmic image that forms part of a larger pattern. Laniakea might be a slightly larger patch, still tiny in the grand scheme of things, still lost in the vastness of the cosmic canvas, and beyond Laniakea, beyond the observable universe, beyond the horizon of our perception, the canvas extends perhaps forever, filled with patterns we will never see. I want you to imagine now that you are floating in space, somewhere in the vast emptiness between superclusters. The darkness is almost absolute, broken only by the faint glow of distant galaxies, too far away to show any detail, just points of light in the cosmic night. This is the void, the great empty region between the filaments of the cosmic web, where matter is sparse and solitude reigns. You look in one direction and see the glow of a supercluster, millions of galaxies gathered together in a great concentration of light. You look in another direction and see another supercluster, equally vast, equally luminous, separated from the first by hundreds of millions of light years of nearly empty space. All around you, in every direction, the superclusters float like islands in an ocean of darkness, connected by faint filaments of matter that you can barely perceive. This is the large-scale structure of the universe, the pattern that emerges when you zoom out far enough that individual galaxies become invisible, and only the larger structures remain. It is a pattern of extraordinary beauty, a cosmic web of light and shadow, matter and void, connection and separation. And it is a pattern that extends to the very edge of the observable universe, filling the entire sphere of space that we can perceive with its delicate tracery. What lies beyond that sphere? We do not know. Perhaps the pattern continues, the cosmic web extending forever into regions we will never see. Perhaps it changes, giving way to different structures, different configurations of matter, different patterns altogether. Perhaps there are regions where the laws of physics are different, where galaxies form in ways we cannot imagine, where reality itself operates according to principles we have not discovered. These are questions we cannot answer, mysteries we cannot solve. But we can hold them gently in our minds, letting them inform our sense of wonder, our appreciation for the vastness of existence. We can let them remind us that what we know is only a small fraction of what exists, that our understanding is limited, that the cosmos extends far beyond our perception, and in that reminder, there is a kind of peace. Because if the universe is infinite, if it extends forever beyond our horizon, then our limitations are not a source of frustration but a source of wonder. We are not missing out on something we could have had. We are simply finite beings in an infinite cosmos, perceiving what we can perceive, knowing what we can know, and wondering about the rest. Let us rest here for a moment, at the edge of the observable universe, before we continue our journey. The cosmic horizon stretches around us in all directions, a sphere of light beyond which darkness reigns. We have come as far as we can go by observation, as far as light and time will allow. And now we must turn to speculation, to imagination, to the theories that attempt to describe what might exist beyond the limits of our perception. Feel your breathing slow. Feel your body relaxing into the gentle embrace of gravity, that patient force that holds everything together. The universe is vast and you are small, and yet you are here, conscious and aware, contemplating immensities that exceed your grasp. There is something beautiful in that, something precious. You are the universe looking back at itself, wondering at its own nature, dreaming of infinities it cannot quite perceive. The journey continues, the mystery deepens, and we are together in it, you and I, drifting through the cosmic night toward whatever truths await us in the darkness beyond the stars. The observable universe is our island of light in the cosmic ocean. It is the portion of reality that we can perceive, study, and begin to understand. But it is almost certainly not the whole of reality. Beyond the horizon, more universe awaits, perhaps infinitely more, extending forever in all directions, filled with wonders we will never see. If the Milky Way is a pixel, then we are pixels within the pixel, tiny points of consciousness embedded in a structure that is itself embedded in larger structures, all the way up to scales we cannot perceive. We are nested within the cosmic hierarchy, small but significant, temporary but connected to something eternal. And that connection is what matters most. We are not alone, we are not isolated, we are part of the cosmic web, threads in the infinite tapestry, pixels in the endless image. Whatever lies beyond the horizon, we are connected to it. Whatever patterns exist in the vast regions we cannot see, our light contributes to them. We are here, part of the whole, wondering at our place in the incomprehensible grandeur of existence. Rest now, as we prepare to explore the theories of the infinite, the speculations about what might exist beyond the observable universe. Let your mind drift like a galaxy through the cosmic void, spinning slowly, peacefully, surrounded by the darkness that is not empty but full of mystery, full of wonder, full of possibilities we have not yet imagined. The horizon awaits, the infinite beckons, and we continue our journey deeper into the night, closer to the heart of the mystery. We have come now to the edge of what can be observed, to the cosmic horizon beyond which light cannot reach us. We have contemplated the vastness of the observable universe, its 2 trillion galaxies and 200 sextillion stars, its superclusters and filaments and voids. And now we must venture beyond observation into the realm of theory and speculation, where science and imagination dance together at the boundary of the known and the unknown. The question before us is perhaps the oldest question humans have ever asked. How big is everything? Is the universe finite or infinite? Does space have an edge, a boundary, a limit beyond which nothing exists? Or does it extend forever, endlessly, without beginning or end, a cosmic stage of infinite extent on which the drama of existence plays out eternally? These questions have haunted human thought since the earliest days of consciousness. Ancient philosophers argued about the nature of the infinite, some claiming that infinity was impossible, a mere abstraction that could not exist in reality, while others embraced it as the fundamental nature of existence itself. The debate has continued through the ages, through the scientific revolution and the development of modern cosmology, and it remains unresolved today. We do not know if the universe is finite or infinite. We may never know, but we can explore the possibilities, and in that exploration we can glimpse something of the grandeur of reality, whatever its ultimate extent. Let me begin by describing what might be the simplest possibility, that the universe is finite. In this scenario, space has a definite size, a measurable volume, a countable number of galaxies and stars. The universe might be shaped like a sphere, curved back on itself so that traveling in any direction would eventually bring you back to your starting point, like circumnavigating the Earth. Or it might be shaped like a torus, a cosmic donut where space wraps around in 2 directions, creating a universe that is finite but unbounded, without edges but with a definite size. If the universe is finite, then there is a largest possible scale, a maximum size beyond which reality does not extend. The observable universe would be a portion of this finite whole, and the unobservable portion would be finite as well, just hidden beyond the cosmic horizon. In this scenario, the question of whether the Milky Way is a pixel in a larger picture has a definite answer. Yes, but the picture itself is finite, containing a vast but countable number of pixels, forming a pattern of immense but limited extent. A finite universe is easier to imagine than an infinite one, even if its size exceeds our comprehension. We can picture a large but bounded space, a cosmic sphere of staggering immensity but definite dimensions. We can imagine, at least in principle, surveying the entire universe, cataloguing every galaxy, mapping every structure. The project might be impossible in practice, requiring resources and time that no civilization could muster, but it is possible in principle. A finite universe is, in some sense, comprehensible, even if it is unimaginably large. But many cosmologists believe that the universe is not finite. They believe it is infinite, extending forever in all directions, containing not just trillions of galaxies, but an endless number of them, never reaching a boundary, never curving back on itself, never stopping. An infinite universe is a very different beast from a finite one, with implications that boggle the mind and challenge our deepest intuitions. In an infinite universe, everything that is possible happens. This is a strange consequence of infinity, but it follows logically from the premises. If space is infinite, and matter is distributed more or less uniformly throughout it, then every possible configuration of matter must occur somewhere. Every possible arrangement of atoms, every possible form of life, every possible history of every possible world, all of these must exist somewhere in the infinite expanse. This means, among other things, that there must be other Earths out there, other planets exactly like our own, with other humans exactly like ourselves, living lives exactly like our own. In an infinite universe, every possible variation of your life is being lived somewhere, by someone exactly like you. Every choice you ever made was made differently by another version of you on another Earth, in another region of the infinite cosmos. Every book ever written, every thought ever thought, every experience ever experienced, all of these are happening somewhere in the endless expanse of existence. This is a dizzying thought, and it is hard to know how to feel about it. On one hand, it suggests that we are not unique, not special, not the only beings of our kind in the cosmos. On the other hand, it suggests that our existence is not contingent, not accidental, but in some sense necessary, guaranteed by the infinite nature of reality. In an infinite universe, anything that can happen must happen, and so our existence is not a lucky accident but a mathematical certainty. Of course, we cannot verify this. The other Earths, if they exist, are beyond the cosmic horizon, unreachable and unobservable. They are a consequence of the theory, not an observable fact. But the theory itself is consistent with what we observe, and many cosmologists take it seriously as a possibility, even if they cannot prove it. Let me introduce now a related but distinct idea: the multiverse. The multiverse hypothesis suggests that our universe is not the only universe, that there are many universes, perhaps infinitely many, each one separate from the others, each one with its own properties and its own history. This is different from the idea of an infinite universe, which suggests that our universe extends forever as a single, connected space. The multiverse suggests that there are many disconnected spaces, many separate realities, each one a universe unto itself. The multiverse comes in many versions, each arising from different theoretical considerations. One version, called the inflationary multiverse, arises from the theory of cosmic inflation, which describes the rapid expansion of space in the first fraction of a second after the Big Bang. According to this theory, inflation might not have stopped everywhere at the same time. In some regions, it might have continued forever, spawning new universes in an endless process of cosmic reproduction. Each new universe would have its own Big Bang, its own expansion, its own history, and its own cosmic horizon, forever separated from all the others. Another version, called the quantum multiverse or many worlds interpretation, arises from quantum mechanics, the theory that describes the behavior of matter at the smallest scales. According to this interpretation, every quantum measurement causes the universe to split into multiple branches, one for each possible outcome. The branches are equally real but never interact with each other, existing in parallel as separate realities. If this interpretation is correct, then there are uncountable universes branching off from every moment of time, each one a complete reality in its own right. Yet another version, called the string theory landscape, arises from attempts to unify the forces of nature into a single theoretical framework. String theory suggests that there might be a vast number of possible universes, each with different physical constants and laws. Our universe, with its particular constants and laws, would be just one possibility among a staggering number, perhaps 10 to the 500 or more. Each of these possible universes might actually exist, somewhere in a higher dimensional space, each one real and complete, and filled with its own forms of matter and energy. These multiverse theories are speculative, unproven, and perhaps unprovable. They arise from our best attempts to understand the fundamental nature of reality, but they venture far beyond what we can observe or test. They are at the edge of science, perhaps beyond it, in a realm where physics meets philosophy and mathematics meets metaphysics. And yet, they capture something important about our cosmic situation, something that resonates with the question we are asking tonight. If the multiverse exists, then our universe is truly a pixel in a larger picture. The picture is not just one infinite cosmos, but an infinite number of infinite cosmoses, each one contributing its own patterns and forms to a meta-reality of inconceivable extent. Our galaxy, in this scenario, is a pixel within a pixel within a pixel, nested within larger structures that themselves are nested within still larger structures, all the way up to scales that have no name and perhaps no meaning. Let us pause here and breathe. These ideas are dizzying, vertiginous, almost too large to hold in the mind. An infinite universe is hard enough to contemplate. An infinite multiverse of infinite universes is almost beyond imagination. And yet, here we are, contemplating it, wondering about it, feeling some faint echo of its grandeur in our small, finite minds. This is one of the remarkable things about consciousness, about the human capacity for thought and imagination. We are small, so very small, and yet we can conceive of infinities. We can imagine universes we will never see, realities we will never experience, scales of existence that dwarf everything we know. Our minds are finite, but they can reach toward the infinite, can touch it in some way, can sense its presence even if they cannot fully grasp it. And perhaps that is the deepest mystery of all. Not the infinity of space or the multiplicity of universes, but the fact that consciousness exists at all, that matter has organized itself into forms that can wonder about their own nature, that can ask questions about infinity and eternity and meaning. The universe, whether finite or infinite, has produced beings that can contemplate it, can study it, can feel awe in its presence. That, to me, is the most remarkable fact of all. Let us turn now to another aspect of the infinite, one that is perhaps more accessible to our intuition, the infinity of time. We have been speaking mainly of the infinity of space, the idea that the universe might extend forever in all directions. But time, too, might be infinite, stretching eternally into the past and the future, never beginning and never ending. The question of whether time had a beginning is intimately connected to the question of the Big Bang. Our current best theory of cosmology suggests that the universe began about 13.8 billion years ago in a hot, dense state and has been expanding and cooling ever since. This seems to suggest that time had a beginning, that there was a first moment, a cosmic origin before which nothing existed. But the situation is more subtle than this simple picture suggests. The Big Bang theory describes the evolution of the universe from a very early state, but it does not necessarily describe the ultimate origin of everything. There might have been something before the Big Bang, some prior state from which our universe emerged. There might be a cycle of universes, each Big Bang followed by an expansion and eventual contraction, leading to another Big Bang and another universe. There might be an eternal multiverse, in which new universes are constantly being born, each one with its own Big Bang, but the process as a whole having no beginning and no end. These possibilities are speculative, like the multiverse theories we discussed earlier. We cannot observe what happened before the Big Bang, if anything. The cosmic microwave background, the oldest light we can see, was emitted about 380,000 years after the Big Bang, and it tells us nothing about what might have existed before. The earliest moments of the universe are hidden from us, shrouded in the opacity of the primordial plasma, and what lies beyond those moments is hidden even more deeply. If time is eternal, if it extends infinitely into the past as well as the future, then the question of origins becomes even more mysterious. We cannot ask what happened at the beginning of time, because there was no beginning. We cannot ask what caused the universe to exist, because the universe has always existed in one form or another. The usual questions of cosmology, the questions about the origin and fate of the cosmos, dissolve into a recognition of eternal existence, a reality that has always been and always will be. This is a difficult concept to hold in the mind, and it may be impossible to ever verify or refute. But it is one of the possibilities that our current theories allow, and it adds another layer of infinity to our contemplations. Not just infinite space, but infinite time. Not just a universe without boundaries, but a universe without beginning or end. Let us bring these speculations back to our central question. What if the Milky Way is only a single pixel in a larger picture? If the universe is infinite, if the multiverse is real, if time extends eternally in both directions, then our galaxy is indeed a pixel, and not just any pixel, but an infinitesimally small one, lost in the endless expanse of existence. The picture of which we are a part would be infinite in extent and infinite in detail, containing patterns and structures at every scale, from the smallest quantum fluctuations to the largest cosmic web, from the briefest moments to the eternal span of cosmic time. What might such a picture represent? This is where our imagination must take over, because science can take us no further. An infinite picture, by definition, contains everything. Every possible pattern, every possible form, every possible meaning is encoded somewhere in its infinite extent. It is not a picture of anything in particular, but a picture of everything, an infinite canvas on which all possibilities are realized. Some philosophers have compared this to the idea of the Library of Babel, a fictional library described by Jorge Luis Borges that contains every possible book that could ever be written. Most of these books are gibberish, random arrangements of letters that convey no meaning. But somewhere in the library there is every meaningful book ever written, or that ever could be written, every true statement and every false one, every description of every possible reality. The library is infinite, and within its infinity all truths and all falsehoods are equally represented. An infinite universe might be something like this. Within its endless expanse, every possible arrangement of matter is realized somewhere. Every possible world, every possible history, every possible form of life and consciousness, all exist in some region of the infinite cosmos. Our world, our history. Our forms of life and consciousness are not unique, but are one instance among infinitely many, one realization of one possibility among all the possibilities that infinity contains. This is a humbling thought, but also perhaps a comforting one. If we are not unique, we are also not alone. If every possible reality is realized somewhere, then every dream we have ever dreamed, every hope we have ever hoped, every love we have ever felt, all of these find expression somewhere in the infinite expanse. We are part of something larger than ourselves, connected to all possible versions of ourselves, all possible versions of reality, all possible manifestations of consciousness and wonder. And in that connection there is a kind of peace. We are not isolated specks of awareness in a hostile void. We are nodes in an infinite network of existence, pixels in an infinite picture, threads in an infinite tapestry. Whatever loneliness we might feel is, in some sense, an illusion, a consequence of our limited perspective. From a larger view, from an infinite view, we are surrounded by existence, embedded in reality, connected to everything that is or could be. Let us rest here for a moment, letting these ideas settle into our minds like stars settling into their orbits. The infinite is strange territory, and our finite minds can only grasp it imperfectly. But we have touched it, however briefly. We have glimpsed its outlines, however faintly, and in that glimpse we have found something precious, a sense of our place in the vast, endless, mysterious expanse of existence. The journey continues. In the next chapter, we will explore the pixel in more depth, wondering what role our galaxy might play in the cosmic picture, what contribution our small, beautiful home might make to the infinite whole. But for now, rest in the infinity. Let it hold you. Let it comfort you. You're part of it. Always have been, always will be. And that is enough. More than enough. That is everything. The theories of the infinite are beautiful in their strangeness, their audacity, their willingness to push beyond the comfortable boundaries of everyday experience. They remind us that reality might be far larger and far stranger than anything we directly perceive, that the cosmos might extend forever in dimensions we cannot see, in times we cannot remember, in possibilities we cannot imagine, and yet here we are, finite beings in an infinite cosmos, wondering about our place in it all. That wondering is itself a kind of infinity, a reaching toward the endless, a touching of the eternal with our brief, mortal minds. We are the universe contemplating itself, the infinite reflected in the finite, the eternal present in the momentary. Sleep approaches perhaps as these vast ideas wash over you. Let it come. Let the infinite be your blanket, the stars your pillow, the cosmic web your cradle. You're safe in the infinity. You're held in the eternal. Whatever dreams may come, they are part of the pattern, threads in the tapestry, pixels in the picture. Rest now. The infinite will still be here when you wake. The mystery will still be waiting, and we will continue our journey together, deeper into the night, closer to the heart of everything.